Okay, so today, instead of me giving you, here's a problem, simplify it, I'm going to actually give you an identity to simplify. Or not simplify, to verify. That's the word. I'm going to give you an identity to verify. So look up here. Tangent of x plus cotangent of x equals secant of x times cosecant of x. If I'm asking you to verify that this is true, I want you to prove that the right side equals the left side. Okay? And we can go about that a few different ways. We could manipulate the left side until it looks like the right side. I guess the left side until it looks like the right side. Okay? And backwards. Okay. Or we can manipulate the right side until it looks like the left side. Or I have one more. What do you think my one more is? I can change the right until it looks like the left. I can change the left until it looks like the right. Or I can change both sides until they look like each other. No matter what, when are you done with the problem? When both sides look the same. Okay? You know you are done with the problem when both sides look the same. So technically, yes, we are proving an identity to be true. But I don't really want you to think of it like a proof like you did in geometry. Okay? What's nice about these is there's a million different ways to do some of the problems. Okay? Just because Madeline does a problem one way and Brecken does a problem another way doesn't mean one of them's wrong. They both can be right and have completely different work. Okay? Some of you are going to like that, some of you are not. Okay? I understand that. But what I don't want you to think is that there's only one way to do a problem. Okay? We can work with the right side only, the left side only, or both sides at the same time. But when you have both sides to equal the same, you're good to go. What's important to understand, though, is that this is not an equation. We can manipulate the right side. We can manipulate the left side. There is no crossing over the equal sign because we don't know if these two things are actually the same. We are proving that to be true. So whatever's on the right side stays on the right side, and whatever's on the left side stays on the left side. We just need to manipulate using our algebra rules and our 8 identities we talked about yesterday. Okay? So I am going to give you some helpful hints. Okay? You kind of experienced this already, but be prepared to think. Okay? These aren't going to come at you right away. And to be honest, the more types of problems you're exposed to, the more confident you're going to feel. Okay? So that's why we have the entire week to work on these problems, because we just need to get the practice so you can get kind of a well-rounded experience of different types of problems. All right? It may help for you to start with the complicated side. Maybe if there's only cosecant on this side, but over here there's like 5 different trig functions, go to the side with more on it, okay? And you have more options to try to whittle away at with algebra and identities. Okay? Doesn't have to be every time, but it could be a good place to start. Okay? If there's a side with addition or subtraction, versus the other side has multiplication and division, it may be helpful to start with addition or subtraction because you know how to make common denominators to combine fractions together. Okay? That is a possibility for you. Okay? So that is something that you can look for when you are doing the problem. Look for opportunities to make substitutions. As I suggested yesterday, you should be doing your homework with those identities in front of you so that you can constantly be looking for opportunities to switch things out. If you see a sine squared x plus cosine squared x, you know you can substitute in a 1. If you see a sine of x over cosine of x, you know you can replace that with tangent of x, or vice versa. Okay? So while we're getting used to this, have those in front of you so that you can look for those things. Try to factor. You're not going to be able to factor in every single problem, but some may have like a GCF, especially. Okay, look for those GCFs. If something's a trinomial, look to see if it factors nicely. Okay, but don't forget about that possibility of factoring. Okay, if you have fractions that are being added or subtracted together, try to combine them. Get a common denominator and add or subtract them together. Okay, especially if on the other side you have like a single, like one fraction or this one term you're trying to get it to look like. On the flip side, it's also possible, like we saw yesterday, to break up fractions. Okay, I think yesterday we had like 2 terms in a numerator, and we split it into 2 fractions. That may be something that you have to do in your work depending on which side that you start on. We saw this yesterday also, multiplying by the conjugate. This doesn't happen very often. We had one fraction with 1 plus sine of x in the denominator. That would be an opportunity to multiply by the conjugate. Okay? Just make sure you're not multiplying across the equal sign. What's on the right stays on the right. What's on the left stays on the left. Okay? And then don't give up. Okay? You are all capable of doing these problems. I know that this feels a lot different than what we're used to, which is a nice change. Okay? I want you to think of it sort of like a puzzle. Okay? You have all of the tools. You have all of the pieces. You just need to put them together. Okay? You have algebra. You have trig identities. If you start on the right side and you're stuck, start manipulating the left side. That's okay. Don't feel like you have like one route that you have to take. So what we're going to do is we're going to do one problem together, and then I'm going to give you an activity to do to help you get some things in order as far as our steps are concerned. So this is the problem that we had on the very first slide where I showed you, hey, this is what we're going to be doing. Okay? So we're going to verify this identity. Go ahead and write it down. We are proving this to be true. Like I said, there is not one way that we have to do this. Your work may look different than somebody else's work, but as long as you mathematically correct, get to the right side equaling the left side, we'll be okay. All right, what side do you want to start on, the left or the right? I think the left one sounds good. We have addition over there. Okay, what might we be able to do with tangent of x plus cotangent of x? We can't just leave them. We have to change them somehow.
We could split them up to put it over sine over cosine over cosine over sine.
Okay, we know that tangent is the same thing as sine over cosine, and cotangent is cosine over sine. You need to write both sides every time. And now I am going to require you to tell me what you did in the step. We used the quotient identity. It is going to be a lot easier for me or you or one of your peers to follow your work if you tell me what you're doing in each step. If you do something wrong, I can at least get the gist of what you were trying to do, and therefore I can help you a lot more. Okay? All right. Now we have two fractions we're adding together. What would be a good idea? Common denominators. So we need to take our first fraction, and it needs a sign of x in the denominator, therefore also the numerator. And then we need to take our second fraction, and it's going to need a cosine of x in the denominator, so therefore also the numerator. Okay. You must show me every step. There is no like combining 5 steps at once. Okay? You need to go itty bitty step by itty bitty step by itty bitty step. That is important. I need, if somebody not in this class, like somebody from Algebra 2 looked at your work, yes, they don't know the identities, but they should be able to tell what you changed each time. All right, now we made common denominators, right? Cosine of x times sine of x was our common denominator. And then our numerators become sine squared plus cosine squared. All right, Nathan asked a question. Can we use the Pythagorean identity on the numerator? What's your answer for him? Yes. Sine squared plus cosine squared is 1. What? Nope, they have to be added together. What can we do next? Huh? Okay, separate them and then use what identity? What, Ryan? Reciprocal. 1 over cosine is the same as secant. 1 over sine of x is the same as cosecant. Hey, does our left side look the same as our right side? Woohoo! Once our right side looks the same as our left side, we are done. Okay. Now, in this problem, we focused solely on the left side, didn't we? Okay. We wouldn't have had to do that. We could have, over here at this point, changed secant to 1 over cosine and cosecant to 1 over sine and gone from there. Okay? But your right side has to look exactly like your left side. And this is a vertical process. We have one line, and then we go to the next one, and then we go to the next one. Some of you did your homework kind of horizontally. Yesterday, that was fine. Your work needs to be organized vertically today. Okay? One step at a time. What's on the right stays on the right. What's on the left stays on the left. Okay. I have something that I need you to do in partners. So, let's see. Between the 6 of you, I need you to partner up, and then you 3 will just work as a group of 3. Okay, so I'll give you the instructions, and then I'll have you come up here and get your materials, okay? So I'm going to give you each 2 pieces of paper. And I know that there's 2 of you, I'll give you guys 3. But I don't want you to do them separately, I want you to do them together. And then at the end, one of you can take one of you takes the other. But what I have is I have an identity given, and then I have the steps over here all mixed up. I need you to cut out the steps, figure out the order in which they need to be, have me check them before you glue them, and then you're going to write what's happening in each step. Does that make sense? So, one of your partner sets needs to come up here to get scissors, glue, and then I will give you the pieces of paper. Okay? Okay. But please have me check them before. So what you can do, both of you take one and cut out the steps. That way that's done. So, because I think I have enough scissors for that. Let's do that.